Okay, this one should be quick. Sample size, there's not a whole lot to do here. We have calculations which don't have a calculator shortcut. That's being able to calculate the needed sample size. We have a lot of stuff similar to the confidence intervals. I'd like to know if I increase my confidence level, what is that going to do to my sample size? If I have a prior estimate, how's that going to affect my sample size? If I use a z instead of a t for sample means, how is it going to affect my sample size? But again, all of those things you can just recalculate if you need to. So basically calculations and then understanding how we can influence sample size, especially with the idea that usually we want to lower sample size. So in terms of lowering our sample size, how to? We can lower our sample size by decreasing our confidence. It's not what we want to do. We don't want to be less confident in our estimates, but it'll get us a smaller sample size, which means less time and money. We can also increase our acceptable error. If we increase the margin of error, well, we're going to end up dividing by a bigger number in our formulas, and that's going to be helpful in terms of lowering my necessary sample size. And the last thing, we have two different things for proportions and means. For proportions, we could use a prior estimate for p hat. If we have a p hat, that's better than using the 0.5 that we have to use if we don't have one, which can end up with a much larger sample size. That's for proportions. So for means, it would be ideal if we could use a z instead of a t. Now, using a z instead of a t means that we have to have the population standard deviation. And if you remember my rant from like a couple classes ago, having a population standard deviation when we're trying to find the real mean is an impossible thing. So means this is a little bit sillier in terms of happening, but if you have to do a t, it is going to cost you more. It's going to take more people with the t distribution to get the same margin of error that you would with the z. So those are the ways that we can increase or decrease our sample size. So I have two examples here from an old test. Both of them are just straight calculation questions. First one says, how many Americans would need to be polled? We're looking for our number of people we need to poll, our sample size, to estimate a proportion who abstain from alcohol within 4% with a 99% confidence. We're only given two pieces here. Within, remember, is a great keyword for our margin of error. I would like my estimate for the proportion to be plus or minus 4%, within 4%. And our confidence level is 99%. Now, like I said, this is something that is only formula based. So you got to come to your formula sheet and go, okay, we're talking about finding a sample size. It's for a proportion, as it said on the question. This is the formula I'm going to use. And we're just plugging and chugging. If this is a free response on the test, write down, even if it's a multiple choice, write down the formula. Even if you get stuck after this, I would usually give you 1 point just for recognizing that this is the formula we needed to use. That z star got real ugly. It's squared. So this is where we want to be. And then we can go, okay, 99% confidence level. Looks like that's a z star of 2.576 from the formula sheet, from the table. Our p, oh crap, we don't have one. We'll just leave that blank for a second. So I expect everyone to at least have this, right? This would be at least one of the points for this question. Now, if we don't have a p hat, which we don't have in this question, this is when we use 0.5. Remember, 50% is the worst case scenario. This is when we hit the vertex of the parabola that this is. So type all this into our calculator, being careful that we don't lose any squareds, because that's usually what happens, losing one of those powers of 2. In fact, I just did it in my calculator and lost one of those powers of 2. We get 1036.8. And remember, the other big piece of this, besides remembering that 0.5, is that we always round up to a whole number of people. 1037 people is what we need. Okay, so the second example here, same idea. It says, suppose you wish to estimate a mean. So we're doing this for a mean. What sample size should be chosen? So again, we know it's a sample size. We know it's for a mean. All right, to find the mean with a margin of error, okay, of no more than $4 with a 95% confidence level. Now, if you have an S here on the formula sheet, let's just look really quick. If you were doing a sample size for a mean and you don't have the standard deviation, that's when you have to do this crazy formula and do the 2 steps. Like I said in class, I am not going to make you do a 2-step calculation because stats people can't even agree on when we should do it, when we should not. So this is really all you have to worry about. I will give you the population standard deviation. And you can see on this old test question, that's exactly what I've done. If we keep reading, oh, look, separate sentence. Suppose we know that the population standard deviation is 24. Sigma is 24. We can use that first formula. We don't have to do the crazy 2 steps. N is equal to Z times sigma all over our margin of error, all of that squared. And then it's just a plug and chug, right? 95% is 1.960. We have our standard deviation. We have our margin of error. Don't forget to square all of that. That's the only mistake I really see on this question. This is 138.29, which we round up to 139. We would need to sample 139 textbooks in order to get out this margin of error of no more than $4. So that's it. That's sample sizes. Okay, so next video will be hypothesis testing, which I'll probably have to split in 2.